This was from the first worksheet. We had one left on the first one, 6A. God bless you. Now, the most important part, guys, is make sure you factor. First, start with your domain. After you factor, do your domain. Get your factors. Don't reduce it yet until you do your domain. After you do your domain, then you can reduce. And make sure you write a reduced format here. Because from then on, after your domain, you're going to use that reduced format. So we found our domain. It can't use 0. It can't use 3. So we remove it from the domain. You're not going to be able to do the range until later. Because if you have a point of discontinuity, you have an asymptote, you haven't seen it yet, you're not going to be able to do that till the end. So then we walk through your sheet. Vertical asymptotes, whatever left in my denominator. So x is equal to 0. Horizontal asymptote, if it's easier for you to do it before you reduce, it comes out the same way because those x's will reduce and they'll be the same ratio. There's 1 here and 2 here. There's none here and 1 here. So the numerator is less than the denominator. When that happens, you get the y equals 0 asymptote. That's probably the nicest one to see on your graph because you can see your graph kind of head away from it. You know, it kind of heads away. Your graph doesn't always do the best job of it. Sometimes it makes it look like that your graph just came here and stopped. It doesn't stop. It just can't get any closer. And again, I said the other day, the color ones, the color graphs are wonderful because the color graph actually shows the color going over the axis. Ours that only print in black don't show that. They probably do, but we just can't tell the difference between the black line and the black axis. It looks the same. So always check. Even though these are making it look like it stops, it doesn't stop. There's no slant. If there's a horizontal, there's no slant, and vice versa. If there's a slant, there's no horizontal. So your zeros of your numerator, well, there's no variables in your numerator, and we can clearly see that it doesn't cross the x-axis. Your y-intercept, follow your rule, is you can either put the 0 in here, or you can put the zeros in here. Either one, it's going to work out the same. You're going to divide by a 0. You can't divide by a 0. That's undefined. And again, come on, ladies.
We have to go downstairs because we want to feel what it works.
Was it working?
Yeah, something's wrong with the pressure with the toilets.
Oh.
They were flushing, basically. So it's more like, wow.
That's gross. Okay, so no y-intercepts. Okay, so you have no x and no y. And clearly your graph showed that, right? Now, here was the part. You factored out this guy. Make this, that you keep track of this. This is your point of discontinuity. So I wrote the fact that we had a point of discontinuity here. And I don't see where I found it. Over here. Here's my point of discontinuity. So I took x minus 3 and set it equal to 0. Just make yourself a note, because what happens is you don't see it on your graph, and you don't really look in your table for it, so sometimes you forget about it. So make a note that you had one, that you had a point of discontinuity, and make sure that you go back and find it. Now, if you graph your original graph, and I think we did this yesterday, and then you graph your reduced graph, they are the same exact graph. The only difference is that point of discontinuity. So it's not noticeable when you're looking at your graph. Find your point of discontinuity, use your reduced version, and plug in your 3 so that you can find what your y is. And again, you can check it. This is like a limit in calculus. This is what we call our limits in calculus. It approaches that y value. It never finds it, but it'll approach it. So we call this a removable point. And at the end of the year, we're going to address these again. So as my graph, my function is approaching this, I actually have to jump over this point. So I have to pick my pencil up and come back down. This is why it's discontinuous. It's a point of discontinuity. That point, you also have to remove from your range. So that's why now After you find anything else, your asymptotes, now you can find your range. Your range says from negative infinity, whoops, stop at the 0, jump over from 0 to that new y value. This new y value. We can't go past this new y value. We've got to jump over it, and then from that y value to infinity. Do your range last. Your concave and your concave up is wrong here. Your concave down, this is not a problem, okay? And this decreasing is wrong also. I don't know why these were wrong. So your concave down, negative infinity, whoops, I hit a wall at the 0. Here's my concave down. My concave up says, okay, go here, concave up, but you got to jump over this point. So we're going to go from 0 to 3, jump over 3, and infinity. Remember, it has to match your domain. I probably took it right out of the book, and the book had the wrong answer, but we'll fix it. Decreasing, same thing. This whole section here, decreasing. From negative infinity till you hit that wall, you were decreasing. Then, end behavior started back up here. You decreased until you hit 3. You jumped over 3, and then you continued on. Okay, does that make sense? We had a little bit of a snag there because we had a point we couldn't use. We have to jump over it. We have to remove that point. And again, your range, don't do your range until after you've done your point of discontinuity and your asymptotes. Was everybody comfortable with this or no? See? Good. This was a nice one. Okay, let me pull up the other sheet. Your rules. We'll work your rules and we'll figure it out. What can I factor out of my numerator? Can I reduce anything? Nope. So therefore I don't have a point of discontinuity, right? Okay, let's hit the domain. So x plus 1, I cannot use a negative 1, so I remove it from my allowable domain. Good? All right. Vertical asymptote. Vertical asymptote, well, since I couldn't reduce anything, it's got to be the same thing. Agree? Horizontal asymptote. The degree in the numerator is greater than the degree in the denominator. So what does my rule say? None. You don't have to write this, no. You just have to say none. You have to say none. Now, if I don't have a horizontal asymptote, I need to check for a slant. My slant says the degree in the numerator is 1 more than the degree in the denominator. So now I have a slant asymptote. And we can kind of see your graph was behaving a little bit strangely. It was kind of tilted over. When it's kind of tilted over, it must probably have a slant. So now, to find your slant, we synthetically divide. Pull out your coefficients. 1, negative 1. Don't forget the 0, because you're 2, 1, 0. What am I dividing by? Negative 1. Good. So I bring down the 1. 1 times negative 1, negative 1. I add it down. Negative 1 times negative 1, 2. I add it down. Now, because I'm 1 more, this starts at x. This is the only part I need. I do not need the remainder. There's my slant asymptote. Add your slant asymptote into your y2. If you put this in your y2, you'll know if that was wrong or right, because while it can cut through, while it can cut through your function, you'll know where it's supposed to be. It can only cut through the end behavior parts. It can't go through the middle of it. So if you kind of see it there, then you're good to go. So let's put all your asymptotes down. So first off, we had x equals negative 1. God bless you. Then we had x minus 2. At the negative 2, it crossed. Okay? Now, from here, you can get a better grip on what's happening to your function. You're not exactly sure where it's going here, but somewhere around here it's turning. And somewhere here it's turning. Again, with the slant asymptote, sometimes you may not be able to see one of these parts because it is off your 10 by 10 screen. If you see one, and you put your slant asymptote in there, it's kind of like your vertical angle things here. If it's on this side, it's got to be on this side somewhere. It's got to be within that too. So you might have to look at your table. You might have to change your window. All right, so let's do your zeros. Zeros of your numerator. So x equals 0 and x minus 1 equals 0. So we know that. So it must have crossed here and then dipped a little and came back up. So now we're kind of a little bit more defined in there. I dipped a little, and sometimes if you want, change your screen. If you can't see your x-axis, keep your x the same and make your 1 go from positive 1 to negative 1. And that'll show your screen a little bit better what's happening at my x-axis. My y-intercept, don't forget to give me your y-intercept. Take out your x values. So I'm 0 over 1. My y is 0. And clearly that makes sense if I used an x of 0. Okay? And do we have max and min here?
Yeah.
We have max and min. If they're tilted like this, we have a max and a min. So this guy over here, what do we call this? Let's call it A. A relative min. Good. Why is it not an absolute min? Because why? It's not the lowest point. Very good. It's not the lowest point. We'll call this B. What do we call B? A relative max. And again, it's not the highest. So it's relative. Make sure you use those words, relatives and minimum, and maximums and minimums for an absolute. Okay, my relative min. Can everybody find their relative min? Okay. Okay, so your relative min should be at, how many decimals do you have to give me? 3. Okay, and your relative max? Should be, and your calculator does weird things, yes. -8 to -10.286. Okay. Are we good with those? Did you get these? Your max? What'd you get? -7.99999?
No, -2.414, -5.83.
You know what? Oh yeah, this is totally off. Okay, this is totally off. So -1. Oops, that's off too. Hang on. It might keep going to a maximum instead of a...
And -2.414.
Oh, I know why. I know why it's not giving it to me because I have my line in here. Hang on. Sorry about that. If you leave your line in there, don't leave your line, your slanted line when you do your max and your mins. It'll mess it up a little bit, like mine just messed it up. -5 point. Okay, are we good with that? For the min, I probably messed up my min too. For the max? Did you get this? Did you get this one? You should get this. Take out your line. If you left your line in there, take it out. Okay, so try it again. I can pull up the calculator on this if you need me to. And this one should be, did I erase this? 414. This one should have been right. Point. So that one should have been right. Okay. Now, increasing, decreasing, this because these have max and mins, you have an increasing, decreasing. And then we have concavity left, that's it. So increasing, work from the left to the right. Your value of y is increasing till you hit that x point. So from negative infinity to that x point. Then I decided to decrease until I hit this x, the little wall there. So I'm decreasing from this point till I hit that x value. It says you can't go past that. Then it jumps up and it starts again and it's decreasing. And it's decreasing again here from the -1 to, where's our point? 0.414. And then again, it's increasing. Okay? It's good. Increasing, decreasing. Just be careful. And your concavities. So concavity up. Which one is my concave up? The left side or the right side? The right. And so what x values am I going from? To infinity. So my concave down is from where? To -1. Good. Good. Okay, so I've got my increasing, decreasing. I'm increasing, then I decrease here, then I came back over here decreasing, then I increased. Your asymptotes do strange things there, so jump over those asymptotes, be careful. Questions on that? That was a good one to walk through. All right, I want to save the first one for last, because the first one's a little tougher. Let's go through this one as well. Sometimes it's hard to know. Yes. Yes. Sometimes it's hard to notice what it's going to look like. So make sure you graph it. Even before you start doing any of these, doing any of the factoring or anything else, just graph it, because it's kind of like nice to know what am I looking at, especially with your rationals, because they're not easy to figure out. They don't follow like set patterns. So you really need to make yourself walk through these. So you see something strange walking through this guy too. So let's see what's happening here. All right, so can I factor this numerator? To what? Not x plus 1, x minus 1. X minus 2, x plus 1. Would that work? Does it give me the negative in the middle? Does it make me able to cancel out anything? No. So even though I have factors, they're a little bit different. I don't have a point of discontinuity. Okay? So, denominator. Let's work domain. I can't use x of 1. I got to take this out of my domain. The reason we factor, even though we couldn't reduce that, we're going to have to factor anyway for zeros of your numerator. So we might as well just factor it in the beginning And then you can tell if I have to get rid of anything, you can tell right there if we have to have a point of discontinuity. Okay, vertical asymptote. My vertical asymptote, I didn't reduce anything. Same as my denominator restriction. How about my horizontal asymptote? The degree in the numerator is greater than the degree in the denominator. What's the rule? None. There is none. No horizontal. So I'd look for a slant. When I don't have a horizontal, right away it says, then you better check for a slant. And I see my graph kind of looking a little strange, like it's a little tilted, a little bent over again. So I probably had a slant. My degree in my numerator is 1 greater, so I have a slant. So let's divide. What do I divide by? 1. Good. Pull out your numerator. Pull out your coefficients in your numerator. So 1 times 1, we add down. 1 times 0, we don't really care about this guy. He's our remainder. So y is equal to what? X. This is where my x is, my 1x. Okay? So I know all those parts. So if you want, you can start graphing your graph. Follow your asymptote. You have a vertical asymptote at x is equal to 1. And you have a slant asymptote that cuts through here. And again, this one is a little bit strange. It kind of followed this around here. You can kind of see where it's bending. It's going down. And then it did the same thing over here. It bent and went down. Okay. Once you get your asymptotes, it's so much easier to sketch. Don't try to sketch it until you put your asymptotes down there. Alright? So zeros of my numerator, my x-intercepts. Zeros of my numerator. So at x equals -1 and x equals 2. And yeah, I can see them. And I can even find them in my table. Okay? Y-intercept, set x equal to 0. Out comes those, out comes that one, and I'm left with -2 over -1. So where's my y-intercept? 2. And confirm that in your table. You should be able to see 0, 2. You can confirm a lot of these on your calculator, but you have to do them out algebraically. Okay? Do I have any concavities? Okay, should we consider those concave down, concave up? What are we considering these? Concave up, concave down. You see them?
They wouldn't both be up.
They wouldn't both be up because this guy's more coming down to concave in. He's more going up to because picture this guy riding right alongside of that asymptote. He keeps going up and up and up like this. So he's more of an up figure. This guy, here's where he's coming down this way. And this is forcing it down. So we've got a concave up. And we got a concave down. So this guy is your concave down, the one on the right-hand side. So from where to where? From this x value, from this x value, am I concave up? -infinity to 1. I have to match my domain on that too. And my increasing, decreasing, do we have any max and mins here? Nope. So no max and mins. We good with this?
Are you gonna give us a revision?
Yes, I am. Just I want to go over the first one because the first one is a little bit different than all these, and it's a little bit difficult to grasp, but I want you to know how to do this. I wouldn't give you number 1 on a test, but I will expect you to know how to do this. This is more of a pre-calc honors problem, but you're taking the same college level class, so this is really, really important. So if you kindly would graph this in your calculator for me. this behaves a little bit different than normal. And it's a little difficult to see. In fact, this is one of the questions that I would give my pre-calc honors on the test, but I would expect you to try this. Now, your calculator does a horrible job of showing this to you, because what your calculator does is this. It's looking like this. It shows your graph, this little piece over here, right? It shows your graph, this little piece over here, and it shows this graph like this. Isn't that what your calculator looks like? Well, we know that can't be true. So we know this guy over here is obviously going out this way. We know this guy over here should be going down, but it looks like I crash into that x-axis. So look in your table for me. Look in your table at -5, at -6, at -7. Where's your y value? According to what I'm used to, is it should be riding along that asymptote. It should be riding along that axis. So my y should be positive. But where is my y at -3, -4, -5? What does it say in your table? Positive or negative? It says your y is negative, doesn't it? Which means I jumped over this asymptote. And then I came back up here to behave along my asymptote. This guy over here is not going to hit that because that's an asymptote. We know that. It's going to go like this and ride along that asymptote. So, number one, your calculator does a horrible job with this. So you need to investigate what's happening. Yeah, you can find your asymptotes. You found your horizontal, you found your vertical, and you tried to graph accordingly. That helps us a lot. And we realize, oops, there's another little problem. There's a point of discontinuity. This one had everything in this. And it had that I jumped over the axis. So here's the problem with this. And I didn't put in where we jumped over that max and min here. I didn't put that in because I just want you to see that it's there, it's happening. So what happens is this. Go back to your calculator. Okay, change your window. Make your window go from x -10 to x +10 and y -1 to y +1. Can you see your left-hand side one jump over that asymptote? It can cross a horizontal asymptote. What it cannot do is cross a vertical asymptote. A vertical asymptote comes from your denominator. It also can cross a slant asymptote if it wants to. But it can never cross a vertical. The concept of an asymptote is to guide your end behavior. So even though your graph crosses over this, what it does is it comes back up and behaves along that asymptote. So if you kind of look at your table and you can kind of see it decreasing, then it starts to increase a little bit. It stays in the negatives, but it picks back up a little bit. So we have a minimum here. So if you do a minimum on your graph, do a minimum and see if you can find where that minimum is. I would do the minimum, do a left down, like from -9 to like 0, rather than move your cursor. Oops, it's not going to do that. I won't go 0. Go to 1. Oh gosh. I don't know why. Somebody put something else in one of these equations. Way in my y0. find that minimum where we dipped to? We dipped over here, and this minimum here would be this point. When you do a minimum, just set your left boundary, rather than move your cursor because it looks like it's straight, to -9. Set your right boundary to -1, because we passed the -1. So it'll find you your minimum. Just so that you know that this had a little bit of a strange case here. Okay? So now, we factor this. We were able to reduce this. This is your point of discontinuity. We had that as well in here. So we had to jump over the 4, over here somewhere. We jumped over that. All right, so now we reduce. Give me a reduced part. From that, you're going to find your vertical asymptotes. That you should have been able to do, right? Probably the only thing you might have missed was that minimum there. You have no horizontal asymptote, you have no slant, well, you have a horizontal, you have no slant asymptote. Because you have a horizontal, you can't have a slant. You can have a vertical and a slant, but not a horizontal and a slant. And you are allowed to cross your horizontal. It still brings it back up there and behaves, but it crosses over it. Your point of discontinuity, use your reduced one and find out what your point is. Reduce this down to 3/2. If you want to leave it to me as a fraction, that is perfectly fine. If you want to go to a decimal, since we tend to use 3 decimals, that is perfectly fine. Your x zeros of your numerator, we got that. Your y-intercept, where's my y-intercept? Not here. My y-intercept, go back to this guy. Whoops, can't use a 0 in my denominator. So no y-intercept. No y-intercept on that. And did we cross the y-axis at all? No. Use your graph to help you confirm that. Okay. Your range, again. Your range, a little bit different this time. We're coming up here to our max. So we're coming up to here. Then, technically, we go here to this minimum here. And I'm sure you didn't have that because you probably didn't see that we had a dip in it. We go from this minimum to infinity. Now the reason we bypassed that one is because this chart couldn't use this y value, 3/2, but it was used on this side. So we didn't have to take that point of discontinuity out of your range. But we did have to go to this little minimum here, which I wanted to make you guys aware of. Let me give you your review before you leave. All right, so the rest and concavities, we have no min, we had a min there, we had a relative max here. We have no min or max in this section over here. So your concave, don't forget to take out your point of discontinuity over there. Take your point of this is a cave up. Take your point of discontinuity out of there. All right, from 3 to 4, and then from 4 to infinity. And here's a cave up here. And I didn't put the increasing, decreasing, because increasing, decreasing goes off of these. So I didn't put those out there.
I still don't understand how you have the minimum because mine does not.
Okay, this minimum. So where are you on your graph?